Okay, so building on from covalent bonding, we're going to look at the shapes of molecules. The shapes of molecules, and this is for the covalent bonds. So just building on from covalent bonds, okay? So when you're asked for the shape, to draw the shape, so for example, if you were asked to draw the shape of methane, you've got to show it in a 3D format. You can't just show it flat. Okay, now we just did the dots and cross diagram of methane, and methane has got four bond pairs, okay? And so because these are pairs of electrons, the pairs of electrons repel. Pairs of electrons repel as far apart as possible. They want to get as away from each other as possible, as far apart as possible. Mathematically, it takes up a shape to take it as far apart as possible. Okay. Now for methane, that shape is called a tetrahedral shape. Okay. So if we draw carbon as the central atom, now you've got to be really careful when you're drawing this, and we draw like this. Now the bond angle in a tetrahedral is a bond angle of 109.5 degrees. Okay, 109. So you're going to draw another bond, but it's going to come down a little bit. So it's not going to be a right angle, it's going to be 109.5. Then you have a bond sticking out, and that's a wedge, a bond sticking out. And then you have a bond, a dash means going back into the paper. So a wedge is sticking out and the dash is going back into the paper, and that is your shape, and has a bond angle of 109.5 degrees. And you need to see the actual 3D model, which is something we'll be doing in the lesson. Okay, if you have something like a BF3, which we were just talking about, and that has 3 bond pairs, and they want to get as far away from each other as possible, that shape is called a trigonal planar shape, and has a bond angle of 120 degrees. 120 degrees. And the way you draw that, because it is planar, which means that it's flat, you just draw it to pointing to the corners of a triangle. So it looks like a triangle, okay, and it's just a flat shape. And that's when you've got 3 bond pairs. Doesn't matter, this could be anything, but if it's got 3 bond pairs, that's how you draw it. If something has got 4 bond pairs, that's how you draw it, okay? If you've got 6 bond pairs, let's do 5 actually, let's do 5 bond pairs. If something has got 5 bond pairs, the shape that it takes, now this is very unusual for A-level chemistry to be asked this, but the shape that it takes, so if we have, for example, let's take for example PCl5, okay, and if you have your phosphorus and you have your chlorine up and down flat, and then from your phosphorus you've got like that, and then you've got one going back into the paper and one sticking out, so the bond angle here is 90 degrees and the bond angle here is 120 degrees. Now it's really difficult, that you need to actually see the models, you need to see this in 3D. So that's something you'll be doing in the lesson. Okay, and this is called trigonal by Pyramidal. It's really unusual for A-level chemistry. The last example is 6 bond pairs, and that a good example of that is SF6, and that takes up the shape, it's called octahedral, and every bond angle going back into the paper, sticking out and sticking out, and every single bond angle is 90 degrees. It's called octahedral, and if you put faces onto this shape, it would make an octahedron shape. Okay, and then next, these are all just bond pairs, but if you have a molecule that has lone pairs, the shape is different, okay? let's take for example ammonia. So we've just drawn ammonia, the dot and cross diagram. Ammonia has 3 bond pairs and 1 lone pair, right? So let's just really quickly redraw it again, just so everybody knows what we're doing. Okay, so ammonia, NH3, H, 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 dot, dot, dot for hydrogen, cross, 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 lone pair. Okay, now the lone pair of electrons are not bonded, and so they're held really close to the nucleus of the nitrogen atom. So all electron pairs repel, but lone pair bond pair, the repulsion between a lone pair and a bond pair is greater than a bond pair because it's being held, lone pair is being held close to the nitrogen nucleus. Okay, so in terms of repulsion, lone pair bond pair repulsion is greater than the bond pair repulsion. Okay, so for every lone pair, the this is approximate. The bond angle, the angle between the bonds, bond angle decreases by 2.5 degrees. Okay, so when we look at ammonia, we go, well, there's 4 bond pairs. It should be 109.5 degrees is what it should be, okay? But because we've got a lone pair, take off 2.5 degrees, and that takes us down to 107 degrees. So the shape for ammonia is called a pyramidal shape, and it has the shape, and it has the bond angle of 107 degrees, and it has 1 in the plane, 1 sticking out, 1 going back, and a lone pair of electrons. And that is how you draw the 3D shape of ammonia. Okay, so when you're asked a question of what shape is this organic molecule, first thing you need to do is you need to do the dot and cross diagram. So let's do that then for water. Okay, let's quickly do the dot and cross diagram for water. You can probably remember how many lone pairs and bond pairs it is. Water is 2 lone pairs and 2 bond pairs. Okay, so now it's got 4 pairs of electrons. Okay, so it should be, really it should be 109.5 really, but you take off 2.5 for each lone pair. So take away 2.5 degrees, take away 2.5 degrees, so you are left with 104.5 for water. Okay, and the shape is called non-linear. Now all electron pairs repel, but lone pairs are held close to the nucleus, and they're not shared, they're not spread out, so they repel more. And so what we say is the repulsion between a lone pair and a lone pair is more than a repulsion between a lone pair and a bond pair, which is more than the repulsion between a bond pair and a bond pair. It's called the electron pair repulsion theory. Okay, so water has the shape, it is non-linear, it has 2 lone pairs, it has a bond angle of 104.5 degrees, and it's called non-linear. Okay, the other shapes, the one I've missed out is the linear shape. So the linear, a good example of linear is when you take CO2. Okay, even though it is 4 bond pairs, it's a double bond, so it's going in the same direction. So it's like it's only 2 bond pairs, and that has a bond angle between the bonds of 180 degrees. Okay, So let's just do one more example. Let's do the bond. What shape and bond angle does an ammonium ion have? Okay, so first thing you've got to do is you've got to draw the dot and cross diagram. Okay, so let's do ammonia first. Let's do ammonia first. Okay, ammonia, one electron, one electron, one electron from hydrogen. Nitrogen has got 5 electrons. So that is ammonia, that's ammonia. Okay, along comes H plus. How many electrons does H plus have? H plus doesn't have any electrons. It is just an empty orbital. Okay, because plus means it's given away an electron. So it's just an empty orbital, and it forms a dative, that's a dative covalent bond. Dative covalent, where a shared pair of electrons, where both electrons have come from the same atom. We put square brackets around positive charge, and that is an ammonium ion. Now I can see that there are 4 bond pairs and there are no lone pairs. So that shape is tetrahedral, 4 bond pairs, and that's a bond angle of 109.5 degrees. Okay, and when you're drawing it, it has the shape N, 2 in the plane, 1 sticking out, 1 going back, square brackets, plus you can label one of them as being a dative covalent bond. Okay, let's do a really quick summary of the main shapes. Okay, quick summary of the main shapes and bond angles. So we have got, right, so if it's 2 bond pairs, I know this is 4 bond pairs, but this is a good example. Carbon dioxide, it's a 180 degree bond angle, and it's called a linear, is the name of the shape. Okay, if you've got 3 bond pairs, good example is BF3, and that has the shape Trigonal planar, and it has a bond angle between the bonds of 120 degrees. Okay, 4 bond pairs is a good example of CH4. And do you remember the name? This is like the summary. Do you remember the name of the shape? Pointing to the corners of a tetrahedron, 109.5. It's called tetrahedral shape. Okay, 5 bond pairs you don't actually need to know. So let's go straight to 6 bond pairs. A good example is SF6, and that has a bond angle of 90 degrees between all the bonds. These are pointing to the corners of a square. Bond angle of 90 degrees is called octahedral, pointing to the corners of an octahedron. If you have got, let's say, 3 bond pairs, 1 lone pair like ammonia, that shape is called pyramidal. Pyramidal, but you've got to be careful with your spelling here as well. Pyramidal, and that has a bond angle of 107, because it should be 109.5, but you take off 2.5. If you have 2 bond pairs, 2 lone pairs like water, that shape is called, can you remember what it is? It's a bond angle of 104.5 degrees, and it's non-linear. Now ideally you actually want to see the 3D shapes, because it'll make more sense if you can see them.